equations. Now, before we actually graph them, I want to talk about solutions, because when you graph a line, all the points on the line are actually what we call solutions to the equation. What does it mean to be a solution? The answer of something. So if I gave you an equation, let's say it looked like this.
I think it's somebody, you gotta plug in X and Y and then graph it like that.
Well, you gotta plug in X and Y. A solution makes the equation true. So let's say I gave you this equation, and this is a linear equation. I know that because it's got an X and a Y, okay? And actually, you could just have an X and just have a Y, but we'll talk about that in a minute. There aren't any exponents or anything. This is the equation of a line. To check to see if a solution, if a point is a solution, because we're going to check points, we're going to plug it in just like you said. So let's see. I'm going to give you a couple points, and I want you to tell me which one is a solution. 3, 4,
No.
or 1, -4. One of those two is a solution and one is not. I want you to tell me which one is and which one is not, and why. Justify what you're doing.
Miss McGee, you gotta plug in, right?
You got to plug in.
Okay. Oh, would it equals the same if you just...
That's exactly right. So look at this. Look at this first one.
1 -4.
Remember, this is X and this is Y, correct? X comes first. Ramon. So I have 3
This is example, right?
times 3, yep, minus 4 equals 7. So think about that equal sign as a big question mark. Is that equal? Does that work? Well, what's 3? I got to do order of operations, right? So what's 3 times 3? What's 9 minus 4? Does 5 equal 7? No, this is not a solution. Okay. How about 1 -4? You check this one and see. You do this one on your paper and let's see. Ramon, do it.
Do what?
I'm dead. Check to see if 1 -4 is a solution for that equation.
1 -4?
Yes.
I don't know how to do that.
Just plug in, bro.
1? I don't even see the 1.
Oh my God.
Oh wait, there we go. I see the 1. Okay.
I know.
1 is X and -4 is Y.
Man, I don't care what you say.
All right, come on, come on. Three times 1.
3.
What happens when you have minus a negative? What happened? Is it a solution?
Yes.
Yes. So 1 -4 is a solution for this line. Does that make sense?
Wait, where did you get 3 from? I don't get it.
I used the equation, that first equation right up there. We're plugging, it's okay, we're plugging into that equation, yeah. Equation given, yep,
I didn't even
yep,
see that
yep.
equation up there.
All right.
It's my fault.
Is this all we doing?
So what I want you to understand from this is what a solution to a line means. That means that the point 1 -4 is on that line. Okay?
So it's just a solution.
If I were to graph that, that would be one of the points on the line because it is a solution. Okay? Does that make sense?
Yes.
Okay. You do this one. Tell me yes or no, is the following a solution? Here's your equation. So it's changing a little bit. Is 4 -1/2 a solution, yes or no, and why? So I'm going to give you a couple seconds and you do it. To check, we need to plug in, right? This is X, this is Y. So we have 4 plus 2, it's not Y anymore, it's -1/2.
Oh, it's negative.
What's 2 times -1/2?
Oh, what did I get?
What's 2? -1.
How you get -1?
If you put this over 1, you do top times top and bottom times bottom. What's half of 2? What is 4 plus negative 1?
3.
Ooh.
You said this did work, Kennedy.
I said it didn't work.
It doesn't
Oh.
work.
It doesn't work.
You try to put her on blast. It does not work. It does not work. Not a solution. Because it does not satisfy the equation. Does that make sense? I don't know. Yeah? Okay. Then let's talk about how we're going to use this to graph a line. Okay. I'll pause. When we have a line, we have some different forms that we have. Y'all graph lines before? I asked you that. I think you probably have. No, not graph lines. Okay.
If you show us, we have
There are a couple different forms that we graph in. So the form that we're going to look at today is called standard form.
Oh yeah, I remember that.
Okay? Standard form of a line looks like this. Now,
we did not learn that.
what are the A, the B, and the C?
Oh, that's like a P word.
Well,
It's a P word.
they're just variables that you can change. If you look at the 2 equations that we just looked at, they're in standard form. It just means the x and the y are together on the same side, okay? 2x plus y equals 5. That's standard form. 1/2 x minus 5y equals 6. That's standard. It is, as long as the x and the y are together on the same side, it's standard form, okay? Yes, Christian.
It's kind of reminds me of something that I did in the eighth grade with like A plus B, something like that. Oh, yeah, I was good at that.
Me too.
I was good at that.
I got confused after a while.
Like A plus B, and then but you will have numbers, and then like, I remember.
But I can't remember the name now. It's kind of coefficient.
These are coefficients. Actually, I shouldn't say that the C is a coefficient. The C is a constant on the end.
Oh, it's moving slow.
It is moving slow. I'm moving slow today, too.
I like Philip.
Okay. The A and the B, come on. The A and the B are coefficients. They vary. They can be different values. Okay. So just like in the examples there, the C is some constant on the end. Remember, coefficients are numbers in front of what?
Letter.
Or variables, right?
Yeah.
Okay. All right. So when we graph these, what we're going to do is we're going to start out by graphing these using a table. Okay? An X, Y table. Okay? That's how we're going to start graphing these. So in other words, we're going to find some solutions, and I'm going to ask that you find at least 4, and then we're going to plot them and connect them. Okay? So let's do it. Y'all good on this, or you want me to wait a second? I think what I'll do is give you a little step chart.
Yeah.
All right. How to graph a line. I'll put the steps on one side. I'll put an example on the other side. How about that? And I'll pause this and give you a second to catch up so we can be together. Record it. First thing I want you to do is solve your equation for y. In other words, get y by itself. I didn't do anything yet.
No, that's why.
Kristen's lost by the words.
All right, no, it's not. No, it's not. Look at your equation over here. I have negative 2x plus y equals 3. How do I get y by itself?
Already by itself.
By itself on one side. Solve.
Oh.
What is with y right now on the side? Negative 2x. So I need to get rid of negative 2x.
Would you divide?
So I plus 2x. I can add that whole piece
Oh, just like do that.
just like that. You would subtract it.
Now the answer would be 3 plus 2x.
So it's gone here. You can't combine those though. And the reason you can't combine those is because they're not like terms, okay? So it's just going to be 2x plus 3 or 3 plus 2x.
So that's
Okay, oh. That's the answer.
We gotta do this on our homework, or we gotta do
That's
this?
just the answer.
No,
That's the solved for y. Now we got to graph it.
You're gonna.
yes, we did. We got
Gonna
homework.
what?
So 3 is y and 2 is x.
We have homework.
You basically just.
All right. I did. I just wrote it another way so it's going to be easier to work with. Okay? Because at some point you can either do it now or you can do it 4 times later when we're finding the points. I'd rather do it one time at the beginning. Okay? All right. Now what we're going to do. And I'm going to, in a few days, I'll teach you a shortcut method for graphing when they're in standard form. But right now, I really want you to understand about solutions and finding points and that kind of thing, which is why we're going through all this.
Wait, Miss McGee, when is the pep rally?
It's still there. Yeah. All right, here's what I want to do. I want to make a T-chart and when I do, I want to pick at least 4 different x values.
I remember like picking different numbers to put in the table. And the same thing.
All right. So when I do this, this is what I'm talking about. I want 4 x values.
2.
Let's go with 0. I agree.
2. Go with. Can we go with 3?
Why don't we do 0,
1.
1, 2, 3. Let's make it as easy as we can. Okay. Huh?
I see.
Yes. What do you do?
You,
Like you just plug it in
plug
each
in
for X.
I need to find the y that corresponds to that.
That's how the in and output on that test.
It is exactly like that. Did y'all hear what I said? It's the input output. I'm not giving you the input this time. You're determining your own input. Now let's find the output. Oh, now you see why we did that. It's not as hard as you thought. All right. So, when x equals 0, okay, so I'm looking at this first one, and if you like to do it in the middle, do it in the middle. Most of you on your test did it off to the side, which is fine. What does y equal? So I do 2, x is 0, plus 3.
It's 3.
It's 3. So this is 3. Is anyone confused on how we find the corresponding y value? Everybody good? Okay, in that case,
6.
y'all 3 find the value for 1. Up front, let's have these 3, this front row find the value for 2.
Wait, like all 4 of us?
4, 5, 6, and then the rest of you find the value for 3.
So what I'm doing is wait. Oh
2.
man, I already got numbers.
1, 2, 3. Find the values real quick and then we'll come together.
Alright, Jordan, what's the value?
You just found them all? Okay.
I went ahead and did it.
Okay, I know what the mom.
Alright, for the value 1. When you plugged in 1, my side of the room over to the right, who's talking, Christian? What did you get? 5. That is exactly right.
Christian, Jordan, you were wrong.
No, y'all did 2, Ramon. Alright, for my front group up here, who plugged in number 2, what did you all get? 7.
Oh yeah, guys.
Jordan,
And for my back part, who?
Brain 9.
9. Good job.
Wait, so it's ours.
Okay. Now, understand this. All of these 4 points, if I gave you that very first equation, negative 2x plus y equals 3, and I said, is 0, 3 a solution? What would you say?
I don't get it.
Yeah.
Every point on the line is a solution to the equation.
And they're all functions.
It would all work if you plugged it back
I
in.
got 3, but where did you get 5, 7, 9? I don't get it.
Plug them in, Ramon. They plugged them in. 2 times 1 is 2, plus 3 would give you the 5. Right? No, it's okay. I'm glad you're asking. Shh, shh, shh. All right, guys, look, we don't do this. We're nice to everybody.
But where did you
Well, I
get
got it
7?
right, Miss McGee.
Okay, so 7 is when I plugged in 2.
We're nice.
So if x is 2,
Haley's not nice.
then y is 2, Zaya, 2 times 2 plus 3,
It's 4.
which is 4 plus 3.
7.
Oh.
And then if you do the same thing with 3, you would get 9. All right,
Okay, I get it now.
so these points, okay, let's write them as points. What's the first point? 0, 3.
Wait, Miss McGee, you were doing it on the simple side, right?
Oh, that's
Yeah.
all.
What's another point?
1, 5.
1, 5, 2, 7, 3.
1, 5, 2, 7.
So what I'm going to do, yes,
This is not hard. Anybody need grass paper?
I'm going to graph the 4 points and connect to make a line. I'm going to go ahead and graph these and show you what we're working with here. All right, 0, 3. This is what we practiced yesterday, graphing these points, right? From the origin up to 1, 2, 3.
Do we need all the connected?
Yes, we're going to have to connect it.
White it out.
1, 2, 3, 4, 5. All right, so this is 0, 3. This is 1, 5.
Yeah, can we do that?
2, 7. No, you don't want to do that because we're going to name lines soon. And 3, 9. You don't have to put the coordinates beside them like I did unless you just want to. Just plot them. They should form a nice line for you.
Yes, ma'am.
So what we want to do is we want to make sure that we connect our line nicely. And because it's a line, it is important.
What happened, Haley?
OMG.
What happened, sweetie pie?
I heard somebody wanted to eat.
It is important, guys. Shh.
Oh, we need to go up a little bit and not stop on the line.
It's important that we keep it going and we put arrows on the end to indicate that it goes on forever. So these are all points on our line. These are our nice line graph, nice straight line. I won't make you use a ruler or anything, but do make sure that they line up. That looks good. Do your arrows on the end. So just to indicate that it goes on forever when you graph them. All right.
We can start over with
I got to show you 2 quick things real quick.
You realize it's Friday,
Yeah. And then I got a game to go to.
All right. 2 quick things.
A party to go to.
There are 2 other types of lines that I need to show you. They're very easy. Okay. These are diagonal lines that we're graphing right now, right? That you'll be graphing in your classwork and your homework in just a minute. You need me to go back? Okay. But we have two special cases. Okay? Sometimes you'll see a line at the equation of a line, and the equation does not have a y in it. Or maybe you see an
When
equation
we see that, we just put special line.
and it doesn't have an x in it. What this means, when you see just x equals something, this is a vertical line. Vertical goes which way? Vertical means what? Up and down. Okay? Here's how I remember it. This is going to look really stupid, but this is how. A vertical line goes up and down. I think about it like a down arrow and an up arrow coming together make an X. So if it's X equals something, it's a vertical line, which basically means if I'm on my graph, I go over 1, 2, 3, and it's straight up and down right there. This is the line X equals 3. Okay? Anytime it's X equals a number, it is a vertical line. Now, if that's true, then what about if Y equals? What do you think? It's a horizontal line. Horizontal line. Horizontal, like the horizon goes across. Okay. So I would go up to 2 on my y-axis, and I would draw a horizontal line. Okay? Very important you keep those straight. X equals vertical, Y equals horizontal. Okay?